This is video 931, and our goal in this video is to be able to graph parabolas written in standard form. So we're going to take a look at, we've already talked about the definition of a parabola in class, but let's take a look at some of the major points and what the graph will look like when we talk about parabolas in this way. So the definition, as a reminder, is a set of all points in a plane that are equidistant from a fixed line, the directrix, and a fixed point, the focus, that is not on the line. So the focus will not be on the directrix, so it has to be off the directrix. Okay. Now, here's a sketch of what it looks like. So remember, all that blue line is all the different points that would be equidistant if we drew it in. Now we're going to look at some characteristics and what the standard form of this equation looks like. So this is a very different standard form than what you saw in the past. In case you can't read that, the standard form is y squared equals 4px, or x squared equals 4py. So this 4p is kind of an interesting piece, and that's going to be the most tricky part of writing rules when they're written in standard form, but it's important to know what p is and what the 4 and the 4 needs to be pulled out in order for us to see what p is. So you'll see that here in some of the examples that we'll do. Okay, so let's take a look. We have p. One thing to note, we have these parabolas. The vertex is on 0, 0, for all of these. The one on the left, of course, is our sleeper, y squared equals 4px. And the one on the right is x squared equals 4py. Now, what's important here is that the p is the most important piece here, is because it is p away is where the focus is. This is the length of p. And of course, that means this is also a length of p from the vertex through the directrix, the line. Okay, so that makes the line at x equals negative p. And here, once again, it's the same idea, but it's all going to be flip-flopped with x's and y's. Now, it's y equals negative p for the directrix on the right. But once again, the focus is p away from the vertex in the opposite direction of the directrix. Okay, so they're both p away from the vertex. So let's see what this means. There's one more important piece that I want you to understand, and you might even have to write down and take notes on, or be prepared to look it up in your book when you're solving some problems. The next piece you want to look at is what's called the latus rectum. The latus rectum is a line segment that passes through its focus. So we have this green line segment. Here's the focus. With this green line segment passing through the focus. Okay, it will always be parallel to the directrix, and the endpoints are on the parabola. And what's interesting about the latus rectum is the length will always be 4p, the absolute value of 4p. In case p is negative, which we'll see on occasion, it's always the length of 4 times p, but the absolute value, so the actual size of 4p. Okay, it will always be equal to that. And what this is nice is it allows us to get 2 more points to graph the parabola. So when you graph a parabola, you're going to graph the directrix, the focus, and then the curve. But the curve will need 3 points, the vertex and the 2 points that are the endpoints of the latus rectum. Okay, so everything you see in black on this graph here is what you would have to graph in order to make a proper graph of a parabola when we're talking about the standard form of a parabola. Okay, so that's going to be important with our next problem here that we'll do one example, and then you will try some on your own. So find the focus and the directrix of the parabola given by x squared equals negative 4y. So first of all, we want to remember our standard form is x squared equals 4py. So what we always want to do is take our rule and rewrite it in that form. So it's written as negative 4y, but I want to write it as 4 times something times y. And in this case, our something is negative 1, because we take out the negative 1 from 4. So that tells me that p equals negative 1. Okay, equals x squared. So we have a parabola. Here's our coordinate plane. that to black. We have our graph. Okay, because it's x squared, it means the parabola is going to open up and down. It's not a sleeper. Remember, a sleeper will have y squared. It'll be a sideways parabola. This is going to be a vertical parabola. It's centered at the origin. Okay, but because p equals -1, that means that my focus is down at -1. So the focus is always p away from the center. Since it's negative, we go down 1. So this is down at -1. And this is my focus point. The directrix is always in the opposite direction, so it's going to be up 1. This is going to be my directrix. And the equation of this line is y equals 1. Okay, the equation of the line will always be y equals negative p, or the opposite of p. Since p was -1, the directrix is at 1. Okay, the last thing that I'm going to do is find the additional points that are at the edge of the lattice rectum. I have this point right here, that's the vertex. But I also need 2 more points in order to draw my curve. Okay, I know those 2 points will be somewhere along this line here, which is the line at the focus. I just need to know where along that line. Okay, so what we do, remember, is we ask ourselves, what is the absolute value of 4p? That's how long this line will be. And so since p is -1, it's going to be the absolute value of -4, which is just 4. So that means that this line starting at the, that will be centered at the focus will be 4 units long. So that means that I'm going to draw a line here that's 2 on each side. Okay, so I'm going to go 2 to the left and 2 to the right. So this would be 2, and this would be -2. And that's going to help me find my 3 points. Now I have 3 points for my parabola. I have my vertex, and I have these 2 points here. Those are the endpoints of my lattice rectum. And now I can sketch in my parabola. Okay, so those are key points in order to graph it when it's written in this form. Okay, so we're going to continue to practice graphing it. Yes, you could go back to the boring way of graphing it, knowing what you know from Algebra 2. But this is an interesting use because P is an important part of this problem. It tells me where the focus is, and when we're talking about real-life applications that deal with the parabola shape that we want to talk about, where the distances are equal from the focus to the parabola and the parabola to the directrix, we want to write the equation in this form so we can find the focus point. Your checkpoints, this is a short video today, your checkpoints are the following 2 problems. So see if you can do number 1. Think about what direction that parabola would go and try to graph it using the vertex, directrix, focus, and lattice rectum. The next thing, you're going to extend it just a little bit further. You're going to make a prediction on what this graph will look like. And then in class, we'll check in with that one. So 2 might be a little hard, but think about how 2, this rule right here that you see in the bottom of this equation, is similar to this rule. And what's different? Ask yourself, what would that do to the graph? And bring your predictions in and draw a sketch so we can see what you think it'll look like. But bring that into class and we'll go over these when it's due.